Hello everyone, this is Manda. My project is about pet facial expression classification with vision transformers. So the motivation of doing this is I know a job called pet communicator that they can tell how the pet feels with the image or with a video, and I would like to think like if we can have this job done by the vision transformers. So to do the job, I used a manual vision transformers, and I also employed a pre-trained vision transformer from the PyTorch. For the dataset, I used the Kaggle dataset that include the face images for various pets such as dogs, cats, rabbits, hamsters, sheep, and for all these pets, they have the categorization of them to different categories. They have angry images and also happy images, sad images, and other images. For these categories, they formed a training set for around 900 images, and this training set include the original image and also the augmented image. So I do not need to augment the image in the data preprocessing. So for the data flow, in the left is the vision transformer from the PyTorch. This vision transformers, I choose this because it's much faster than the CNN, and it takes shorter time to train the models with more approaches. So on the right, it's the data processing flow. So I got a transformer encoder, and I got multi-head self-attention block, and I do a layer norm after it, and I have another multi-head attention here with a MLP block, and I have a normal layer after that, and I have a sequential ones that comes to the Gelu softmax and get to the end. So for the code, I have some problem running the space, so I'll just show it with my Colab. So say I have loaded my models here. I have the VIT model and I have the pre-trained model. I'll show you the pre-trained VIT path here. So I have already got the model loaded here. So let's see an example. So this is one image from the test set. Let me categorize. From the past, you can see that the original category is in angry. So the ground truth is angry. But this model make a wrong prediction because I'll explain that later because I have a high training loss. But if we select another one from this, for example, this one. Oops. And try it again. This prediction is correct. I find that for the entire data set, the model have higher prediction when the image is cat, and also they have a relatively higher prediction when the category is happy. So let's take a look into the result here. So for the manual vision transformer, both training loss and test loss is relatively high. And also the test accuracy here is not very stable. And for the pre-trained vision transformers, the training loss converges better, but the testing loss is still very high. And this indicates a problem of overfitting. And we can also see in the accuracy part, the test accuracy increased a little bit, but it refused to increase after maybe the 20 epochs. But the text accuracy refused to change after the 20 epochs. But the training accuracy gradually grow and approaches to 1. And for the prediction result comparison, the manual vision transformers can predict the wrong prediction, because this is not a happy cat. They can predict a wrong prediction, and the probability is very low. In comparison, the pre-trained vision transformers have relatively higher prediction, relatively higher probability, and the prediction is more accurate. And for the most time, the pre-trained vision transformers can get the prediction right, but the probability is still relatively low compared to a good vision transformers. I think this undesired performance is because the data set is still relatively small. 1,000 image is not enough for a challenging task like emotion realization by images. And also this data set include multiple animals. So I think this kind of mess up the vision transformers, because they need to identify the animals first and then identify the emotion. And so for the future direction, first we'll attempt to fine-tune the pre-trained model or the manual vision model to a larger data set. And we'll also explore more diversity in the emotion categories, because we only have 4 categories for now. And I think more diverse the category can result in more precise result and more applicable to the application in real world. And here are some references. I have the reference for the PyTorch vision transformers and the facial dataset. I have the model uploaded to the Hugging Face, so they are right here if anyone want to take a look. Yep, that's it. Thank you.